Welcome dear students, I am Dr. Lalit Kumar Gupta here to discuss with you the module 1 of design of RC structural elements. This subject belongs to the 5th semester. So today we will discuss the fundamentals of the RCC. RCC is the reinforced cement concrete. So in the reinforced cement concrete we will discuss about the first today what is the concrete is and what is the reinforcement, because the reinforced cement concrete is made of the reinforcement and the concrete. Okay, so today we will start it. Before going on that, we know that the vision mission of the department. So these are the vision and mission of the department of civil engineering department. After that, so RCC is the made of the two things, that is the first one is the concrete, as I already told you, and the second one is the reinforcement. So the combination of this concrete and reinforcement is known as the reinforced cement concrete, that is the RCC. Why we required this RCC? Because we have the one product, that is the concrete, which is very good in compression. Concrete is made of coarse aggregate, fine aggregate, cement and water, but it is only good in the compression. So that a structure is having not only the compression stresses, that is also having the tensile stresses. So for that tensile stresses we required to provide, because we require to provide the reinforcement, because concrete is not enough to get those tensile stresses. So that is why we have provided the reinforcement. So okay, so today, so reinforced cement concrete is the combination of the concrete as well as the reinforcement. So generally when we are talking about the concrete, so first in this lecture we will first cover the concrete. What is the concrete, what is the made of that, what are the properties of the concrete, and this in second we will discuss the reinforcement. Okay, so first if I am talking about the concrete, so what is the concrete is, as I already informed you that told you that concrete is the combination of these four things. If the traditional concrete we are talking, first one is the cement, then we have the fine aggregate, okay, then we have the coarse aggregate and the water. This is the combination of, and it is the concrete. So concrete is good in compression strength. So we have the coarse aggregate, fine aggregate. So major portion of the load taken in the concrete by the coarse aggregate. So coarse aggregate and fine aggregate, so how we will define it? So we have the 4.75 mm sieve which divides the aggregate. The retained aggregate on 4.75 mm is known as the coarse aggregate, and the passing aggregate from the 4.75 mm is termed as the fine aggregate. So this is we have the concrete. So now if I am talking about the properties of the concrete, so properties of the concrete, first you can say how we will represent the concrete. So we represent the concrete like this. You can easily see that how we can represent the concrete like this. We can represent the concrete like this, that we always write the grade of the concrete like this, M, and what is the grade we have. Okay, so if I have the 25 grade, and then I write that concrete like M25. So this M is what M represents. M represents the mixing of those materials which we used for the production of that concrete. So what are those materials? That are the cement, fine aggregate, coarse aggregate, and water. Okay, so this is the N25. If the value after that M, that is the characteristic strength of that concrete which we obtained after that 28 days of curing in Newton per mm square. So this is how we represent the concrete first. After that we have we prepare the concrete mix. We have the traditional ways in which we prepare the concrete by the volumetric proportions, or we can use the design proportions. For that we have the design proportions. We have the one code, that is the IS 10262 2019. That is the code we have, which we use for the designing of the concrete mix. After that is if we are talking about the stress strain curve behavior when the load is applied on the concrete, then if we plot the stress and strain curve, then we found that for the concrete it is the non-linear curve. Then the modulus of elasticity and the brittle of the concrete is increased when we are increasing the grade of the concrete. Okay, if the grade of the concrete will starts from the example that will starts from the M10. Okay, so this is the least grade of concrete we have, and then we have the concrete of M60 also. So this is the, if as we increase the grade of concrete, we found that modulus of elasticity and the brittleness of that concrete will also increase. Characteristic strength of the concrete is that strength which we obtain when we prepare the concrete mix and we prepare a 1 cube of 150 mm size. So if then we tested after the 28 days, then we get the strength, that is the compressive strength, not the characteristic strength. The characteristic strength is that strength when we have, if we casted the 100 cubes, so only 5 cubes we allowed, that that will show the below that strength of for which we have designed. Okay, so if the 5% specimen is only allowed, if we found that only less than 5% specimen we have which is showing the less strength, then that strength which we obtained, that is that compressive strength, we call the characteristic strength. Okay, every individual cube of the concrete showing the compressive strength, but when we are talking about in terms of designing, then we have to use the terms characteristic strength. So as per the definition, if you go, then the characteristic strength is defined as the strength of the material below which not more than 5% of the test results are expected to fail. So this is the characteristic strength. After that we have the various methods. So now we are using the limit state methods. So in further classes we will discuss what are the various methods, what are the drawbacks of those methods and all. So if I am talking in terms of limit state method which we are using in present time, so for that we have the partial safety factor. So for concrete we have that 1.5 partial safety factor, and for the reinforcement for steel that value is the 1.15. Then similarly in terms of characteristic strength, we have the characteristic load, which is the characteristic load is that value of the load which has a 95% probability of not being exceeded during the lifetime of the structure. So that is the characteristic load which we generally took for when we are designing that concrete. So that is the characteristic load. Now if we are talking about the grade of concrete, so for this we have an Indian standard, that Indian standard is the that Indian standard, that is IS 456-2000. That 456 is the number of that code and 2000 is the revising year. In last time it revised in 2000. So in this code we have all the specification, all the guidelines, how we have to design, we have to take the materials, and all the criteria for designing of the RC structure elements is given in this code. Okay, so as per this code we have one table. That table shows us the what type of grade of concrete we have. So this code divides the concrete into two types of, first one is the ordinary concrete, second is the standard, and third one is the high strength concrete. So the ordinary concrete, this code says the ordinary concrete, that is from the grade M10 to M20. After that for the standard concrete we have the grade from M25 to M55, and above then from the M60 and above that we call the high strength concrete. So if I again define this, that what is the grade of the concrete. So if M10 is the grade of concrete, then M represent the mix and 10 is the characteristic strength of that concrete, not compressive strength, that is the characteristic strength. So characteristic strength, every compressive strength is not a characteristic strength, but if we have the characteristic strength, that is the compressive strength. Okay, so the 10 Newton per mm square for M10 is the characteristic strength. Okay. So this is how this IS 456 defines the various type of concrete we have. After that, this is one table again from the same code, IS 456-2000. In this code we have if for what purpose we are using the concrete. If we only using the concrete, then that concrete we call the plain concrete. If we are using the concrete with the reinforcement, that in that concrete we call the reinforced concrete. So for that, how much should be the minimum? If the concrete is the plain concrete, if the concrete is the reinforced concrete, then what should be the minimum water cement ratio, maximum water cement ratio, minimum cement content, minimum grade of concrete for the various exposure. So in this code they have defined what is the various 5 type of exposure, that starts from the mild to extreme. Okay, as the exposure condition is becoming severe, then on the basis of that they divide it on the basis of that how much minimum cement content we have to take, how much maximum water cement ratio we have to take, how much minimum grade of concrete we have to take, that is defined in this table of that code. Now this is a one more table in which that cement content, the how much is the cement content should be shifted as per the size of the coarse aggregate. As we know, if we have the higher size of the coarse aggregate, then in that case with the surface area of the coarse aggregate will reduce. So in that case we require the less cement content. If we have the smaller size of coarse aggregate, in that condition we require the higher side of cement, because the specific surface area of those coarse aggregate will increase. So that is why this table indicates that if in last table which I have discussed with you, in last table you can see this table is for the given for the 20 mm grade of 20 mm size of coarse aggregate. So for that, so this is the standard one. If we go beyond the 20 mm size of coarse aggregate, then we have to reduce the cement content, as I told you that because the specific surface area of the concrete of the coarse aggregate has reduced. And similarly, if you reduce the size of coarse aggregate from 20 mm to below side, then in that condition we have to increase the cement content. So that is the next table of that code, that is the table number 6. So in this you can see, if we are going from 20 to 10, then we have increased the 40 kilogram per cubic meter cement. Or in this, if we are going from 20 to 40 mm size of aggregate, then we have to reduce 30 kilogram per cubic cement. So this is how this table defines. Now we have the concrete. We are doing the concreting in such severe conditions like sea water, okay, in which we know the various salts we have. So in that case the IS 456 suggests that we should go for the, if we are going for the plain concreting, then we have to go use the M20 grade. If we are going for the RC concreting, then we have to minimum grade we have to use M30 grade. Okay, so this is this one we use. Okay, and also suggest that if you are using the special type of cement, that is the slag cement or pozzolana cement, that is better in such conditions. Okay, if we are going for the post tensioning works, concreting for the post tensioning works, then we have to use M30 grade of concrete. Or if we are going for concreting for the pre-tensioning works, in that condition we have to use M40 grade of concrete. These all specifications which I am discussing with you is given in the IS 456. Now we are coming to the fresh property of the concrete. So fresh property, we have the, always when we are talking about the fresh properties of the concrete, we always talking that how much is the slump. But we are to measure the workability, we don't have the only test slump, we have the other tests also. So one of the test is the compaction factor test. So on the basis of that what kind of use of the concrete, on the basis of that we decide the workability, that what workability of that concrete should be we have. So that is defined in this table. Okay, acceptance criteria of the concrete, when we are producing the concrete, we have to check the strength of that concrete, that for whatever grade of concrete we are designing, in that case, so how much sample we have to take. So that sample, how much samples of cube we have to casted of 150 mm cube. So how much number of that depends on the how much quantity of that concrete. So this is the table in which that they have defined that if the quantity of surveying between the quantity of the concrete which we are producing, that is the between 1 to 5 cubic mm, in that the number of samples should be the 1. Okay, similarly this table defines the quantity of concrete and how much is the number of samples you have to take. After that, hardened property of concrete, earlier we have discussed the fresh property, in which we are talking about the slump and the compaction factor. Hardened property, if I am talking about, then I have the tensile strength of the concrete, that is the as per the IS 456, that is the 0.7 root FCK. FCK is the characteristic strength. We represent the characteristic strength of the concrete by the FCK. Okay, abbreviation we are using here. Elastic deformation, so this is again we have, that is the modulus of elasticity. So that is the 5000 root FCK we have. Okay, so this is how we can calculate these two properties, hardened properties. Next properties we have, that is the shrinkage. So shrinkage value, that is approximately we took the 0.003. So that 3 times 0.003 is the shrinkage value which is prescribed by the IS 456. And again the creep of the concrete, that is depends on how much is the deformation is there. On the basis of that we will take, and we have the factor for that. So that is the factor we have, that is the depends on the how much days of loading we have. So on the basis of that we take the creep coefficient to calculate the effect of creep. Okay, this is table again from the IS 456. So this is the creep which we have discussed, as this is as per the loading condition, that how much for how much duration we are giving the load. Okay, so on the basis of that we took that creep coefficient, and after taking this creep coefficient we calculate the creep. Now this is the first part of this lecture, that is the concrete. Now the second part of the lecture is the reinforcement. This is the combination of the concrete and the reinforcement is the RCC. So now what is the reinforcement? So reinforcement is we provide in the concrete reinforcement, we are providing in the concrete to resist the tensile stresses mainly, but the reinforcement is also good in taking the compressive stresses. So in that is why we are providing the reinforcement, because the concrete is having the very less tensile strength, as you have seen in the earlier slides, that tensile strength we have, that is the 0.7 root FCK. 0.7 root FCK. If we have the M25 grade of concrete, then the FCK equals to 25 Newton per mm square. 25 Newton per mm square. So in this condition, if I am calculating for this grade of concrete how much is the tensile strength, then I put the values, so I easily get that is the 3.5 Newton per mm square. So we can easily see that for M25 grade of concrete, the characteristic strength for that concrete, the characteristic compressive strength of that concrete is the 25 Newton per mm square. If we am talking about the tensile strength, then in case of the tensile strength, that is the 3.5 Newton per mm square. So that is why there is a need to provide the reinforcement. So that reinforcement is mainly provided to take the tensile stresses. Okay, so in that case now we have the what are the materials we have which we can use in the RCC for as a reinforcement. So that those materials are steel, copper, aluminium, plastic fiber, bamboo, but mainly we are using the steel. Why we are using the steel? Because there are multiple reasons behind it. The first is that is the economical, then the other materials, then the high tensile strength, but the most important reason is that the thermal coefficient value. So thermal coefficient value for the steel is similar to the concrete. So that is why we prefer the steel as a reinforcement. That is the main important reason, that the thermal coefficient value of the concrete and the steel is approximately similar. Now what type of steel reinforcement we have? So generally we have the two type of steel reinforcement which we have divided into two parts, but first is the mild steel and second one is the HYSD bars, HYSD steel or HYSD bar. So mild steel, this is the plain steel which we represent like this, Fe250. This is the mild steel bar, that is the Fe250. So in this the tensile strength of that, yield strength of that we represent like this Fy. So that is the 250 Newton per mm square for the mild steel. This is we represent like Fe250. So that will be represent, we can say that the yield stress for that steel is the Fy, and that is the 250 Newton per mm square. So that is the one, and all the specifications is given as per the IS 432/1966. All the specification regarding the mild steel is given in this Indian standard. After that, the second type of reinforcement we have, that is the HYSD bar, HYSD steel. So high yield strength deformed bar we have, that is the deformed bar, and we have in this we have the two grades. One is the Fe415 and second one is the Fe500. So again for this, for if I am talking about Fe415, if you are talking, then in this case Fy is, that is the yield stress, is the 415 Newton per mm square. Or if I am talking Fe500, that is the yield stress for that, that is the 500 Newton per mm square. And the specifications for these HYSD reinforcement, that is given in the IS 1786 1979. This is we have after, before going on that, earlier I have discussed with you the partial safety factor for the limit state. In the concrete I have discussed with you that for that partial safety factor for the concrete is the 1.5, and for the steel or for the reinforcement, that is the 1.15. So why is the partial safety factor for concrete is the 1.5, and why is the partial safety factor for the reinforcement is 1.5? That is the reason behind this, that the concrete we produce on the site. So we have the multiple, we have to take care for the safety, we have to take higher safety conditions for the concrete, but the reinforcement we have, that is the factory made product. So in that case we easily achieve the whatever the safety requirements we needed, so for the production of that steel. So that is why we have taken the less partial safety factor of reinforcement as compared to the concrete. So this is the reason we are taking the higher value of this one of partial safety factor for the concrete in the limit state method, and the same for the reinforcement. So this is the, we have the reinforcement type of reinforcement we have. So you can see this is these plain rain bars I am talking. So that is the, this is the Fe250, and this is the deformed bar. So this may be Fe415 or Fe500. Now as you can see yield strength, if I am talking strength wise, mild steel bar or HYSD bar, we can easily see that the mild steel bar having the plain bar, so that is giving the less gripping with the concrete. So that is why we have used the deformed bar. So in terms of the yield strength, you can say the mild steel is having the yield stress up to the 250 Newton per mm square, but the HYSD bar is having the 415 and 500 Newton per mm square. So that is the having the higher values. So this is the same, that deformed bar having the higher strength than the mild steel, okay, because of the gripping with the concrete. And the mild steel reinforcement is the highly ductile, because the ductility of the reinforcement depends only on the basis on the carbon content. So carbon content is less in the mild steel, so that is why that is the ductile, more ductile than the HYSD bar. But as we increase the carbon content, the strength will increase, but the ductility will reduce. So so you can easily understand that carbon content is high in the HYSD bar. So high is carbon content, so HYSD bar is having the high strength but less ductility as compared to the mild steel bar. This is the stress strain curve we have. Stress strain curve for the mild steel, in which we have all these points. This curve is drawn between the strain and the stress. Okay, so A, B, C dash, D, E, F, these are the points we have. So proportional limit up to which point the A point is the proportional limit up to the material behaves as per the Hooke's law. What is the Hooke's law is that stress is proportional to strain. So up to point A, that is law valid. After that the B point is the just next to that is the elastic limit. The B, what is that up to B point, if we remove the loads, then the material regain its original shape. So that is the behavior of the mild steel up to that point B, that is the elastic limit. If the material cross this point B and reaches the yield point, then after that it is very difficult then it is not possible to that material to regain its original shape. So that is the yield point. Okay, so in this we have the mild steel, only we have the mild steel, we have the two yield points, upper point yield point and lower yield point, because of the behavior of the molecules of the mild steel. After that we have the ultimate point, that is the maximum stress that mild steel achieves on that, that is the ultimate point, that is the E, and after that we have the point F, that is the breaking point on that, and that is the fracture point, breaking point you can say, and at that place that mild steel bar has totally break down at that point. So that is the, this is the graph we have plotted when we are applying the tension force on the tension force on the mild steel bar. On the basis of that we have plotted this curve. So this is the stress strain behavior of the mild steel. Then we have the various size of reinforcement. On the basis of that we have taken the cross sectional area of the reinforcement. So when we are talking about the, so we have the reinforcement bar from the 6 mm diameter to 50 mm diameter reinforcement bar we have, and the cross section area in respective of that bar we can easily calculate. If the diameter we have, that is the D, okay, then area is the, if the diameter is the D, in this case the area of that bar, cross sectional area of that bar equals to pi by 4 D square. So we can easily use to find out the cross sectional area, because we always calculate the cross sectional area of the reinforcement which we required. On the basis of that we select the what diameter of bar we have to use. Okay, so this is the diameter bar we have in the market from the 6 mm. Generally these bars are the mild steel bars. Okay, and from here the HYSD bar starts. So this is the, we have the size of various size of the reinforcement. So this is how the two important part of RCC, first is the concrete and second one is the reinforcement. The combination of these two is the reinforced cement concrete, that is the RCC. Thank you.